Our initial design for the concrete boat was elevated on the sides with a triangle point in the front and in the back. The goal of this project was to make the boat be able to float for at least 10 seconds without sinking or having water spill into the boat, and to be able to hold at least 1 pound. The materials we used were water, concrete, styrofoam, sand, and gravel. The first prototype we did didn't float in water. It sunk, water leaked in, and it wasn't able to hold 1 pound. So we redesigned it, and each time we changed our mold since the previous one didn't work. We redesigned the project about 2 times before we came up with a final design that actually worked. And each time we changed the amount of the ratio for aggregates since the previous designs didn't work. The final time we redesigned, we used more styrofoam and we had a new design. This time our design worked and was able to float in water and hold up to 1 pound.
That was a lot more.
No, that was a lot more than you thought. I had a little bit more to that.
Oh, my bad.
What?
Wait, try that.
Did that not hit you? Oh,
Just a little bit at a time. Since now you have too much water, you want to add a little bit at a time. But throw it onto the liquid side. Okay, now try that.
it's actually floating. How much is it? How much is this? This 1 pound?
Did it sink?
I don't think it's. Alright, this video is for the windmill project that we made, and the project was to create a windmill through NX that could, when placed in the wind tube with the fan on the other side that spun and generated the wind, could like create more than said volts, which in our case was at least 2.4, which was for a B. Our constraints for that was the diameter, which couldn't be more than 11 centimeters. We had to find the size of the blades, the pitch, and the shape, and the basic design, and how many of those blades we wanted. And the materials that we were given were through NX to create a 3D printed design and then just test that out. Our initial prototype was our drawing that we have right here, which is basically what we went with, which was 9 blades, 1.5 centimeter width, 2 centimeters for the center, and then 45-degree pitch. And that's basically what we went with. And then we printed it out, and after we got our piece back, we tested it by putting it inside the tube, letting it run, and then seeing how much it could generate on average, which was about like 1.9 to 2, so around a 90. And yeah, we tried to correct it, or at least went with a different design to see if anything could be improved, but it was just a bit difficult just because it was our first time going with NX, so we weren't really, acquainted with the software, so we just stuck with our basic design, which did pass and did do well. So yeah.
The project ping pong launcher. The goal of the project was to shoot a ping pong ball over 2 meters using the least amount of rubber bands, with the limit being 3. Some of the constraints that we faced was time, definitely, because it felt that it was shorter than previous projects. Also, we weren't allowed to print off as often as we were for the windmill. For materials, we used a 3D printer, rubber bands, and a ping pong ball. For our design, for our initial prototype, the shaft was too short and so was the catapult, so we had to redo both parts, but the base went really well. Our design came off based off the original model in class, but we switched a few things. One of them being that instead of an angle of 90 degrees, we went with a 45-degree angle because we thought it would launch the ball farther. And Atra did the catapult, Michelle did the base, and I did the shaft. When we were working on the design, we looked at the original to see what we believed could be improved on, and an example was the angle, but also we had to increase a lot of our measurements for it to work better. We tested it by attempting to launch a ping pong ball, but we definitely had to redesign, like I mentioned before. We redesigned the shaft and the catapult to be longer. And then for our final result, we're still not sure because we still have to test it on.